Hello, my name is Evie and I'm a second-year engineering student studying creative technology and design at the University of Colorado Boulder. Today's lesson is all about how wedges were used in pyramid building, and I have HelperBot here who knows a lot about wedges to help out. Do you remember the 6 simple machines? HB does. They tell me that the 6 simple machines in engineering are the lever, the pulley, the screw, the wheel and axle, the wedge, and the inclined plane. Today we're going to be focusing on the wedge. Let's say we've been hired to build a pyramid and we're starting at the construction part of the process. We need to cut rock from the ground, cut the rock into the shapes we need, transport the stones to the pyramid site, and lift the stone into place. This is a lot of work, so let's focus on the process of cutting and shaping the rocks first. What simple machine do you think we could use for this? That's right, the wedge. Wedges look something like this and are used to separate objects. This can be done by applying enough force to a mass in order to get it to move. Another word for this is acceleration. If you hit something in a smaller area, that focused, unbalanced force causes the object's particles to move around and shear or slide apart. In simpler terms, wedges are often used to cut objects. This is what we need to do in order to cut and shape our stones for our pyramid. It's important to choose the right wedge when you're cutting material. For example, it's good to pay attention to the materials. Some larger rocks need a sharper and metallic wedge to cut, while a softer object can be cut with a softer material. It's important that the material you're using for the wedge is tougher than the material you're cutting though. Otherwise it won't cut, or it may wear out too fast. The sharper a wedge, the less force you'll have to use to cut something. So, you don't have to do as much work. That's because a sharper wedge has a smaller angle, which gives you a greater mechanical advantage. It spreads the force over a longer distance, making cutting easier. The last important thing when deciding on, or making a wedge, is to choose its width. A larger width leads to larger cuts and larger building blocks, with fewer cuts needed to separate materials. Meanwhile, a small width is for when you want something more precise, for smoother and cleaner shapes, although it'll need a lot more cuts to get it the way you want. These are all very important design choices you want to think about when choosing your wedge. These decisions and trade-offs are essential to any engineering design. Now, for our pyramid stones, we need strong, large, and sharp wedges in order to remove the rocks from the ground. For example, a pickaxe could work well. Then, in order to shape them, we need a smaller and sharper wedge to cut them. A chisel may work well here. This is how we're able to make the building blocks for our pyramid. Now that you know a little more about wedges, can you think of any examples in your daily life or in the present day? Do you know what they do? Some examples I can think of are jackhammers, chisels, forks, nails, axes, bulldozers, and more. All of these simple machines can be used to separate objects from each other. The wedge is a very useful tool. Engineers still rely on wedges today, combining them with other simple machines to make powerful tools that help us build everything from houses to skyscrapers. I encourage you to keep in mind the design choices we thought about when choosing our wedges for the pyramid, and how you can apply a similar thinking process to your own engineering projects. Anyways, that's all for today. Thanks for watching, and we'll see you next time. Check out the full lesson on the TeachEngineering website. Then, check your knowledge of wedges used as simple machines and solid rock to building block.